Greetings. Welcome to the first of two videos on Desmos's activity Marble Slide Exponentials. In this activity, we'll play a game that requires us to recall how the value of b changes the graph of an exponential function. We will also learn how the graph can get shifted up or down, or left or right, by the values of h and k respectively. So the equation we're going to be working with is y equals a times b raised to the x minus h plus k, where the value of a is a scaling factor. We won't be considering that very much in this activity. And the value of b is the exponential base. Recall that if b is between 0 and 1, then it's an exponential decay curve. If b is greater than 1, then we have an exponential growth curve. What we're going to discover in this activity is how the values of h and k shift the graph up, down, left, or right, respectively. Let's start off with the value of k, or a vertical translation. The value of the k is going to shift the graph up or down. In figure 1, we compare the graphs of the following: f of x equals 2 to the x, g of x equals 2 to the x plus 3, and h of x equals 2 to the x minus 3. Let's go ahead and actually do those in our calculator and see how that works. So let's get a little interactive here. So if we go to our calculator and go to y1 in the y equals menu and put in 2 raised to the x power, and we press graph, we'll see our old pal, an exponential growth curve. Now remember that this curve has as its horizontal asymptote the x-axis here. So let's go ahead and put in the second function, g of x, that they gave us in the activity. And they said that that was 2 raised to the x. Now be careful here, make sure you get down out of the exponential position and put in the plus 3. That 3 is not up in the exponent place, it's down here being added to the 2x. And let's go ahead and graph that and let's see what happens to our function. And what we see is that our graph has been raised or shifted up by 3 units. We can actually come in here and put into y3 the equation of the horizontal asymptote, which would be y equals to 3. And I'm going to go ahead and change the plot type here to a dotted line. It'll take a few times to get through, but I'll get there eventually. If you just go off to the left there and keep hitting enter, it'll change the plot type for you. And press graph, and didn't make it too much of a dotted line, but you see that that's where the horizontal asymptote would be. Okay, let's go ahead and get rid of that one because this is going to get in the way of our further exploration here. And let's put in 2 to the x minus 3. And again, being careful to get out of the exponential position before we put in the subtract 3. There's our stock, y equals 2 to the x. There's y equals 2 to the x plus 3, and there's y equals 2 to the x minus 3. And so what we see is that our stock curve, this one right here, was shifted up or down by whatever that value that was added on to the exponential. In the first case, we did a plus 3, so it shifted it up by 3. In the second case, we did a subtract 3, so it shifted it down by 3. Okay, let's go back to our activity here. And so a few things to notice that what that does to our function, that shifting. By shifting that, it shifts our y-intercept and it changes our range. So notice that this shifts the horizontal asymptote up or down by the value of k. This means that the equation of the horizontal asymptote is now going to be given by y equals to k. You will also get a change in the range of your function of y equals b to the x plus k. And the range will now be from k to positive infinity, since we have shifted the horizontal asymptote up to y equals k. Also notice that your y-intercept and the vertical intercept, in the case of our textbook, get shifted up or down by the value of k. In the graph of y equals a times b to the x plus k, the y-intercept is going to be given by 0, comma a plus k. But as you'll see in the example that we'll do just in a minute, your best bet is just to evaluate the function at x equals to 0. Also note that the x-intercept, or your horizontal intercept, now exists on the graph of y equals b to the x plus k when k is less than 0. We'll talk about that more and how to find that in the next lesson. So let's take a look at y equals 3 to the x plus 21 and go through this example here, see if we can find the vertical intercept or the y-intercept, the domain, and the range. The horizontal asymptote also will be asked to be found here, but we want to give that back as an equation. So to find the vertical intercept, we're going to do that when x is equal to 0. So let's go ahead and shift over to the whiteboard and do that real quick. So we see that our function here that we were given is y is equal to 3 to the x plus 21. And what they ask us for in the first thing here is to find the vertical intercept. So remember that the vertical intercept is the same thing as saying the y-intercept, which is the same thing as saying that x is equal to 0. So if x is equal to 0, then that gives us y is equal to 3 to the 0 plus 21, which gets us 1 plus 21, which is equal to 22. So it tells us that the vertical intercept would be at 0 by 22. And that's the way I would recommend finding your vertical intercepts when you get asked those questions. Okay, let's go look at part B here, or number 2. They want to know what is the domain of this function. Well, all exponential functions have the same domain, and it's pretty nice. We just have to remember that it's from negative infinity to positive infinity. And that's because if we were to take a quick, very sloppy graph of this, where this went through y is equal to 21, which is our horizontal asymptote, we would see that this function would look not quite unlike, but similar to this. It would be taken off like that, where that's the y-axis and that's the x-axis. So notice that the horizontal asymptote at y equals 21 is going to shift it up, but it doesn't change our domain in any way, shape, or form. This is still going from negative infinity down that way out to positive infinity out this way. Okay, they want to know the range. Well, let's go back and take a look at our graph. That's going to help us with the range here. Let's get back to the right place. There we go. So if we were to look at the range here, notice that it's going to start here at 21, and then it's going to go off in that direction up towards positive infinity. So that tells me that our range is going to begin at 21, but not included because it's an asymptote. It doesn't get to touch it. And then it's going to go off to positive infinity. All right, let's get back to where we want to be here. And they want to know the equation of the horizontal asymptote. So let's go back to the picture here. We already gave that. There's our equation of the horizontal asymptote. We see that it's at y equals to 21. Okay, so hopefully that's making some sense out of what we do with vertical translations. Let's shift our focus now to horizontal translations. In the horizontal translation, the number that does the shifting is going to be attached to the x. And so notice that in this example here, we've got f of x equals 2 to the x again, but now it's 2 to the x plus 3. And notice that 3 is up in the exponential position. Contrast that to our previous example here, where it was down being added to the base raised to the x. In other words, with the exponential function with a constant added to it. Here, it's part of the exponent. So make sure you keep that distinction clear. So this time, it's not quite as intuitive. When we had a positive 3, we shifted up. When we had a vertical translation, and we had a negative 3, we shifted down. Well, in the case of horizontal translations, it's kind of bass-backwards to that. Notice the point plotted on each of the graphs. It's at 0, 1 on the graph of f of x. The plotted point is 3, 1 on the graph of h of x. And we see that it's at negative 3, 1 on the graph of g of x. That as the graph shifts to the right 3 units when h of x is equal to 2 raised to the x minus 3, and to the left 3 units when g of x is equal to 2 to the x plus 3. So let's pause for a moment and let's take a look at that on our calculator and actually verify that. So let's get our calculator back out here. Let's clear out the functions in our y equals, and let's start all over here. So we'll put in 2 to the x will be our stock function in y1. And now we're going to put in 2 raised to the x. And let's see, what was our first one here was going to be at x plus 3, if I recall correctly. This would be our g of x, yes, so let's do that. So x plus 3. Now notice this time I do not shift out of the exponential position. I leave it up there. And so now let's press graph and let's take a look at those two graphs compared to each other. So the first one is our stock one. That's 2 to the x. and this is 2 to the x plus 3. Now notice what happened. This point right here is at 0, 1. That point right there, 0, 1, was shifted over 3 units. It's now at negative 3, 1, but it was shifted 3 units to the left. Similarly, if we come in here and we put in y equals 2 to the x minus 3, oops, put that subtraction in there, and we press graph, what we'll see is that this function gets shifted 3 units to the right. In other words, this point that was at 0, 1 now is over here at 1, 2, 3, 1. So notice this point is right here, okay? So the, excuse me, right here, my bad pointing. So the thing to notice is that when we have the value added in at the exponent place, in other words, it's up here in the actual exponent position, that value does a horizontal translation either to the left or to the right. And it's a little bit backwards from what we would expect. When you have a plus 3, it shifts it to the left. Well, in this case, we had a minus 3. Sorry, I'm getting the right spot here. We get a minus 3, then we were shifting to the right. So make sure you keep that in your notes. Make sure you keep that clear in your head. Okay, so let's go ahead and summarize this here for a moment. Let's think about this. So a good way to think about this is going on is if we rewrite this as y equals b to the x plus a negative h, which just means we take the opposite of h to figure out whether we shift to the left or the right. So in summary, a graph is shifted by the value of k vertically. If k is positive, it'll move the graph up. If k is negative, it'll move the graph down. Graph is shifted by the value of h horizontally. If h is positive, it'll move the graph to the left, and if h is negative, it'll move the graph to the right. If you would like a more detailed explanation of this, please go ahead and click on the link on the page. It'll take you to section 4.2 of Scottsdale Community College's algebra textbook. So we're going to end this video and come back and take a look at the activity in the Desmos function or application and see how to actually get through some of those screens.